So now we're going to look at some problems for chapter 5 and look at constant composition. So two samples of carbon dioxide from different sources. One sample produces 4.8 grams of oxygen, 1.8 grams of carbon. Other sample has 71 grams of oxygen and 6.4 grams of carbon. Show these results are consistent with the law of constant proportion. So we just pick one, and we'll pick oxygen to carbon. And so they both equal 2.7. So because of that, it does fit, in fact, with this law. So this is consistent with that. So let's write some chemical formula for each compound. So 2 aluminum atoms for every 3 oxygen atoms. So that's Al2O3. So 3 oxygen atoms for every sulfur. That's going to be SO3. So SO3. And then 4 chlorine atoms for every carbon atom. And that's CCl4, so carbon tetrachloride. So looking at this and use this table to decide which atom goes first. So determine the number of each type of atom in magnesium phosphate. So the phosphate group is a polyatomic ion, and that means that many atom ions, and there's 2 of them. The parentheses means there's 2 of them. So from this, there are 3 magnesium as signified by the 3 subscript, and there's 2 units of phosphate. So that means there's going to be 2 times 1 for phosphorus, so 2 phosphorus, and then 2 times 4 or 8 oxygens inside of this. And this whole compound has then 3 magnesiums, 2 phosphoruses, and 8 oxygens. So what are these? What are these atomic elements, molecular compounds, or ionic compounds? So krypton, that's a noble gas. That's just an atomic element. Cobalt-2 chloride, that's an ionic compound. It's a metal and a nonmetal. Nitrogen is a diatomic element, so it's a molecular element. Sulfur dioxide, this is a molecular compound. They're both nonmetals. And then potassium nitrate, this is a metal with a polyatomic anion, so that is an ionic compound. So how to write formulas for ionic compounds. So write the formula for the ionic compound that forms between aluminum and oxygen. So aluminum is going to have a +3 charge as its position on the periodic table. Similar, oxygen is going to have a -2 charge. So look at these, and aluminum you see is in group 3A, and oxygen is in group 6A. So we have the numbers 3 and 6, and we have to find the lowest common denominator, and it's going to be 6, because 3 and 2 are prime numbers. So the 3 and 2 are prime numbers, and then for there to be the 6, you need 2 aluminums, and for the -6 you need 3 oxygens. So that's how you solve that. So we'll write formulas for ionic compounds that has polyatomic ions. So the formula between calcium and nitrate, you can see they were given the charges already. Calcium is +2 and nitrate is -1. So you need 2 of the -1s to counteract the +2, and so it's going to be calcium. It's going to be calcium with the parentheses around the nitrate, the subscript. So here's a table showing the different polyatomic ions, or very common polyatomic ions. And then you drop the 1 with the calcium, so just write the calcium and then the nitrate in the parentheses, and the 2 indicating there's 2 of the nitrates. So naming ionic compounds have a metal forms only one type of cation. So here magnesium and with 2 fluorines. So when you say the name, you say the entire, even though the magnesium is a +2 ion, you just say the word magnesium, and then for fluorine, you take its root word fluor, and then put in the IDE, so that's magnesium fluoride. So that's how you would name that one. So naming compounds that have more than one type of cation. So with lead and chlorine here, so the Cl has a -1 charge. The 4 -1s means that the lead is +4. So you name this as lead fluor chloride, and the 4 you say the Roman numerals IV in parentheses. So this is lead fluor chloride, or writing out lead in parentheses IV, so 1 less than 5 for lead 4. So name this polyatomic ion CrO4, that's chromate. And so it's a polyatomic ion, and it's a in the name, even the potassium is a +1 ion. You would just say the word potassium, and then and then there's only, well, then you just say potassium chromate, and you, as a chemist, would also understand that chromate has a -2 charge. So naming molecular compounds, name each of these. So say for A, you say the first word, carbon. We wouldn't say mono, but this is straight up carbon, and there's 4 chlorines, so it's carbon tetrachloride. Then here for boron, B is boron, and there's 3 chlorines, so that's boron trichloride. And then sulfur, and then there's 6 fluorines, so the 6 is hexa, so sulfur hexafluoride is the next one, the way you name that. Naming binary acids. So for the aqueous H2S, this would be the hydrosulfuric acid. Is the because you have the sulfur there, and the H for the hydrosulfuric acid is the way you name that one right there. And let's do another one. This is the acetate anion, so you have to use the ic. So that would be acetic acid by changing the 8 to ic. And let's name some of these compounds. So the first one, CO, it's 1 carbon, 1 oxygen. Even though there's 1 carbon, we don't say the word mono. We drop the mono for the first. And then there's 1 oxygen, though, so we have to do it for the second one, so that's carbon monoxide. So the second one, CaF2, that is an ionic compound, and that's calcium fluoride. So there's only 1 type of ion there. So HF, aqueous, that's an acid, so it's going to be the hydrogen fluoride, but the acid, it's hydrofluoric acid is the way you say that. The next one, ionic compound, there's more than 1 charge possible for iron, and the nitrate is a -1 ion, so that means that the iron is a +3 charge, so you say iron 3 chloride, and the 3 is in Roman numerals in parentheses in the middle. Last one there, this is, that one's perchloric acid. It's an oxyacid, and it has the 8 on it, so it's the ic. So perchloric acid, perchloric acid, and that SO3 is sulfite. So when you write the acid, it's going to be sulfurous acid, going with that. So calculating formula mass. What's a formula mass for carbon tetrachloride? So you have to look at the periodic table and look at the molecular weight or the atomic weight of carbon. And it's 12.01, and chlorine is 35.45. So there's 1 carbon, and then there's 4 chlorines. So you have 12.01 times 1 plus 4 times 35.45, and then you add these all together, and you get 153.8 atomic mass units there for the mass of carbon tetrachloride. So constant composition of compounds. We've kind of covered this before, but I wanted to do this one again. So one of the sample produces 8.08 grams of sulfur and 1.51 grams of carbon. Another one produces 31.3 grams of sulfur and 3.85 grams of carbon. Are these results consistent? So just take a fraction. Just make sure you're consistent, and then carbon's a lower number, so put it on the bottom. It's because I like bigger numbers better than fractions. And you find out they are not consistent with each other, so there must be some 2 different substances in here. So this is interesting. This is either a failed experiment or there's 2 different substances. So cover this a little bit more, but I wanted to cover it again. The number of atom in lead chlorate. So this would be lead 2 chlorate. So there's 1 atom in lead, but then the 2 and the chlorine there. So there's 1 there, so it's going to be 2 chlorines, and then 3 times 2 is 6 oxygen atoms. And we are done. Thank you.